Hello everybody, I'm Roman Rodriguez and we are on lesson 2 of chapter 7 circular motion and gravitation. In lesson 1 we did cover the following topics. We did discuss about uniform circular motion when a body is moving in a circle with uniform speed, its velocity changes because the direction changes at every instant. We also discussed about the centripetal acceleration, that centripetal acceleration mathematically can be calculated as AC is equals to V squared upon R. And then we also went on to discuss centripetal force, that we did derive the value of centripetal force Fc is equals to mv squared upon R, when we know that the force is equals to mass into acceleration according to Newton's second law of motion. We also did discuss the difference between centripetal force and centrifugal force. Um, Also, we did go on to discuss law of universal gravitation. This law was first discovered by Sir Isaac Newton, and according to him, we know that the Earth attracts body towards its center, and every body attracts every other body with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between the centers. And we also came across the gravitational constant capital G, which was discovered a century later after Sir Isaac Newton discovered the law of gravitation, and it has a constant value that capital G is equals to 6.67 times 10 raised to the power minus 11 Newton meter square per kilogram square. Uh, then we use this formula of Newton's law of gravitation to derive or to calculate the mass of the Earth. Today, I'll just do a quick recap of the mass of the Earth, and we will go on to discuss about the acceleration due to gravity, how it changes with altitude. Um, as you know that value of g, that is small g, acceleration due to gravity decreases with altitude. So let's do a quick recap of the Earth. As you know that the mass of the Earth may be determined with the help of Newton's law of universal gravitation. We know that the Earth attracts every body towards the center, and consider the mass of the Earth over here in this case as capital M, and radius of the Earth as R. And when we take a body to the surface of the Earth, um, so since the body, the mass, the radius of the body which is taken to the surface of the Earth is very small compared to the radius of the Earth, so it can be negligible. It is negligible, and we neglect the value of radius of the body, and radius of the Earth. Well, if we know that that is 6.38 times 10 is power of 6 meter, and the value of acceleration due to gravity is 9.8 meter per second squared, and the gravitational constant is 6.67 times 10 is power minus 11 Newton meter squared per kilogram squared. So we get the mass of the um, Earth equals to g, that is small g acceleration due to gravity, r squared, that is the radius of the Earth, uh, upon capital G, which is the gravitational constant. When we substitute all these values, we get the mass of the Earth as 5.98 times 10 to the power 24 kilogram, which is approximately 6 times 10 to the power 24 kilogram. So this is what we had done in the previous lesson. Now we move to the next topic, that is variation of g with altitude. Now we all know that the acceleration of gravity is the acceleration imparted to a body by its own weight. So let's consider a body of mass m on surface of the Earth. The gravitational force of attraction between the body and the Earth is equal to the weight of the body. So since g is the gravitational constant, capital G, and me is the mass of the Earth, and the uh, the acceleration due to gravity is small g, decreases with increasing the distance from the center of the Earth. As you can see over here, that the g, the acceleration due to gravity at any point above the surface of the Earth will vary inversely as the square of the distance from the point to its center. So if a body is moved up to a height h, distance from the Earth's surface, the acceleration due to gravity at that point is given by this equation, as you can see. So uh, when we step by step, if you look at uh, the calculation, then we finally get the expression that indicates that the acceleration due to gravity decreases with altitude. right? So the equation shows that the greater the value of height, the smaller is the value of the acceleration due to gravity, or value of g decreases with altitude. So with this we conclude topic on value of acceleration due to gravity. Small g decreases with that. So we covered these two topics, a quick recap of mass of the earth and the variation of g with altitude. So hope to see you in the next lesson. Till then, take care.